Hey guys, today we get to start 3-7. We will be doing 3-7 in two parts. So today's part 1, where we learn how to find the determinant of a matrix. We'll be doing 2x2 and 3x3 matrix determinants today. By the way, a rule is that it has to be a square matrix in order to have a determinant. So a square matrix means it has the same number of rows as columns, right? So a 2x2, 3x3, 4x4, etc., etc. So let's start with a 2x2. These are pretty easy. If I give each element A, B, C, D, like alphabet here, the determinant can be given by A times D minus B times C. So basically, I kind of take this diagonal multiplied together minus this diagonal multiplied together. And then just simplify. So let's do an example. So this diagonal, -6 times 8. And then I do this diagonal, minus 10 times -7. And then just simplify. -48 minus a -70 is a double negative. And so my answer is going to be 22. That's all you do. Let's try 3x3. We're going to call this, so this top one, if I didn't say, is called a second order determinant because it's a 2x2. So if it's a 3x3, as you can predict, it's going to be called a third order determinant. And honestly, it works the exact same way. It's just because of there's more rows and columns added, it's going to take us a little bit different of a route here. So the first step that you're going to want to do is actually rewrite the first two columns on the right hand side. So this -5, -2, -4, then rewrite this 9, -1, and 6. Actually pause for a second. I forgot something up here. We know that matrices are written with these nifty brackets, right? Check it out. When you want to do a determinant, they're just going to use, they kind of look like absolute value bars for the matrix. Those are your directions. If you see somewhere where it just says, here's a matrix with absolute value bars, those absolute value bars are telling you, find the determinant. So they're not really absolute value bars, that's just kind of what they look like. All right, so what we're going to do this time, so I rewrote those first two columns, and what you're going to do is you're still going to multiply the diagonals. So I'm going to get a different color here going. So -5 times -1 times 2. That's going to be +10. The reason I wrote those next two columns, or those first two columns over here on the right, is because that way I can just continue down with that pattern. It gives me a nice visual there. 9 times 5 times -4 is going to be -180. 4 times -2 is -8. -8 times 6 is -48. What you're going to do is add those three numbers together. So if I add 10 minus 180 minus 48, right? Because adding a negative, same thing as subtraction. That's going to be -218. This, so in my 2x2 matrix, if I kind of come back up here, 1, 2, 3, 4, what we just did was that diagonal. So when we did a 2x2, when we did that other diagonal, that's what you're going to be doing now. So just do the exact same thing. I'll switch colors here. 4 times -1 times -4 is going to be a +16. -5 times 5 is 25. -25 and -25 times 6 is -150. 9 times -4 is -36. Right? Because it doesn't matter what order you multiply in. I'm just doing some mental math here. Add those three numbers together. Going to be -170. Okay, so we just did that diagonal. So if you remember on our top example, you did this diagonal minus this diagonal. That's what I need you to do now. Take this diagonal. Whoa, what just happened? Minus this diagonal. And of course, it looks like I ended up with a double negative. And my final answer is going to be negative 48. Okay. That's all we're going to do for now.